All right, so now we have the 6-2 polynomials and linear factor notes. We're going to start this one off by reviewing our factoring. So factoring quadratics, x squared plus 7x plus 12. Remember, we're looking for two numbers that are going to multiply to give us this last number, and then add to give us this middle number. So we used tables for this. But we can just jump right into this since we did a lot of this. Two numbers that multiply to give us 12, add to give us 7. That's going to be 4 and 3. Doesn't matter the order. You could have x plus 3, x plus 4, or you can have it like I'm going to have it here, x plus 4, x plus 3. Okay, again, we're just looking for two numbers that multiply to give us that last number and add to give us the middle number. Same thing over here, two numbers that multiply to give us negative 20 and add to give us 8. So go ahead and think about that one for a second. Two numbers that multiply to give us negative 20 and add to give us positive 8. So since the last number is negative, that means we're going to have different signs. So we're going to have an x plus and an x minus. And this is going to mean that our numbers, the bigger number is going to have to be positive because we have a positive here in the middle. Smaller number is going to be negative. All right, so two numbers that multiply to give us 20 and add to give us 8. So you could run through some factors of 20, like 5 and 4, 2 and 10. I don't know, can't think of some other ones. But anyway, eventually 2 and 10 are going to be the ones that you're going to get to. So 2 and 10, we got to figure out which one goes where. And again, like I said there, the bigger number is going to go with that plus sign. So x plus 10, x minus 2. All right, last problem we have here on this one is finding the product x plus 1, that quantity being squared. Now what you don't want to do is just square each of these and say x squared plus 1 and say, all right, that's it, x squared plus 1, I'm done. No, finding the product here means I have x plus 1 times x plus 1. Okay, so we got to multiply that whole thing out there, all right? So we don't want to just do x squared plus 1 squared and just, leave it at that. So we got to multiply this out. So x times x, that's going to leave us with x squared. And x times 1 gives us x. Then we're going to jump down here and say 1 times x, that's going to give us another x. And then 1 times 1 gives us 1 plus 1. So you can see if we would have made that mistake and just did x squared plus 1, we would still have those two, but we'd be missing these two parts here in the middle. So we don't want to miss those pieces. All right, so we have x squared. Add our like terms, x plus x gives us 2x, so plus 2x, plus 1. Final answer there, x squared plus 2x plus 1. All right, next. No notes or anything like that. We're just going to jump into our examples here. So we want to write this expression, x plus 1, x minus 2 being multiplied together. We want to write that in standard form. So we talked about standard form in the 6-1 notes. That just means we're going from highest power to lowest power. All right, so what we're going to do here is we're going to take all this, multiply it out, and then write it in highest to lowest power. Now, you can multiply this out all at once, but my suggestion to you is just take 2 at a time and multiply it out. So we just did x plus 1 times x plus 1. I'm just going to go through that step and multiply it out again. This x minus 2, I'm not going to do anything with that yet. I'm just going to bring that along. I'm actually just going to rewrite that out front here. X minus 2. I'm not doing anything with that yet. So the first thing I'm going to do is I'm going to multiply this stuff out. So we just did it. I'm going to go through all the steps again, even though we just did it in that last problem. I'm going to do it again. So x times x is x squared. And x times 1 is x. Multiply the 1 through. 1 times x gives us x. And 1 times 1 gives us 1. Right? Should be no surprise there. We just did this, so hopefully we get the same thing because it's the same problem, so at least that portion of it. All right, add the like terms. X squared plus x right here in the middle. X plus x gives us 2x. And then we got that 1 there, so plus 1 being brought down. Okay, now we still have one extra step here because we're not finished multiplying this out. We still have this x minus 2 that needs to be multiplied through and distributed through this polynomial. So now we have more stuff that needs to get multiplied through here, though. So this x minus 2 has to get multiplied through everything. All right, so what I'm going to do here is I'm actually going to move this down a little bit because I don't want it to run into that problem above it here when I'm multiplying it out. So, all right, here we go. X times x squared, add your exponents. 1 plus 2 gives us x to the third. X times 2x, that's going to give us a plus 2x squared. One more time, x times 1, that just gives us a plus 1x, or you can just write x. Now we got to take this 2 and multiply it through, but remember, it's not a positive 2, that's a negative 2. So negative 2 times x squared gives us negative 2x squared. Okay, now that's going to have something happen to it there in the next step. We'll get to that next. We're going to keep distributing this through here first. Negative 2 times 2x. Negative 2 times 2 is a negative 4x. Last step, negative 2 times 1. That just gives us a negative 2. All right, now the last thing that we have to do here is combine our like terms. So x to the third, there are no other x to the thirds, so bring that down. But when we look at our x squared, this is what I was talking about here, 2x squared minus 2x squared, those ones are going to cancel out. For the x's, I have plus x, and then I have a minus 4x. So that's going to give me a minus 3x. And then I got this minus 2 here at the end. So I'm going to bring that guy down, minus 2. And there's your final answer. Again, any of these steps that you need to see again, rewind, back it up, and just make sure that you can follow through with what's happening there. Next problem. We want to write this in factored form. So kind of going back to what we did in the first two bell ringers, but there's some extra stuff that needs to be factored out of these. So first thing, if you remember when we did our factor flow chart, the first thing we always looked for is a GCF. So I look at this, I see a 2, a 10, and a 12. Those are all even numbers, so I can take a 2 out of each of them. But also I notice that each of these terms has an x, so I can take an x out. So that's how we always want to start whenever we're looking at any kind of factoring. We always have to look for a GCF and see, can I take out a common factor? What is the greatest common factor that I can take out of all of them? All right, so we always want to start with that. Now what am I left with? Well, if I take a 2x to the third and I take a 2x out of that, I'm left with an x squared. Next term, 10 divided by 2 gives me a plus 5. And then I started with x squared, which means I started with 2 copies of x. I took 1 out. I'm still left with 1. And then plus 12 divided by 2 is 6. Started with 1 copy of x, but I took that one out, so I'm done. But we want this completely factored. That is not completely factored, so we need to finish this out. The 2x is still out front, but the rest of this can be finished. So we need to take this, x squared plus 5x plus 6, and we have to factor that, so we got to find out what two numbers are going to multiply to give me 6 and add to give me 5. So pretty quickly we should be able to recognize that that's going to be an x plus 3 and an x plus 2. 2 times 3 is 6. 2 plus 3 gives me 5. So here's my final answer. Completely factored, that's what we get. Number 3, same thing. Again, I would suggest you pause the video. There's the problem. I would suggest that you go ahead and take that problem, write it down, try to get the answer, and then just try it out for a minute or so, and then come back and see that you have the same thing that I get here when I go through and do it. So hopefully you did that, and now you're back, and you're going to check your answers with what I have here. So I'm going to look at this. The greatest common factor that I can take out of here, 6, 15, 36. The biggest number here that I can take out is a 3. And again, they all have an x. All right, so what am I left with? Well, I took a 6 divided by 3, left me with a 2. X to the third meant 3 copies of x. Took one out. There's 2 copies left, so x squared. Plus, nope, not a plus. That's a minus. My bad. Back up. Minus 15 divided by 3 gives me 5. And then x squared divided by x means I'm left with another x. And then minus, I had a 36, and I divided out a 3, so I'm left with 12. All right, now you had 2 methods that you went over in class on how to factor a trinomial that looked like this, right? 2x squared minus 5x minus 12. You had 2 ways that you could factor that. So you could use those methods and figure out, how did you do this? What did you, whichever method you preferred to use. I personally do it a little bit differently, so I'm going to show you my method now, and maybe you like this way a little bit different or a little bit better, and this is entirely up to you. If I'm confusing you by showing you yet another method, I totally apologize, and that's not my intention to confuse you further. But to be honest with you, don't completely remember the methods that you learned in class, so I'm going to show you the ways that I do it, and it's not completely different from one of the methods that you did, so I just kind of finish it out in the x. So anyway, I'm going to get back to this here. So multiply your outside numbers. 2 times negative 12 is negative 24, and then I put my middle number at the bottom, so my negative 5 goes at the bottom. Then I try to find 2 numbers that multiply to give me negative 24 and add to give me negative 5. So my 2 numbers that multiply to give me negative 24 and add to give me negative 5, that's going to be a negative 8 and a positive 3. And then I take the 2, which is this number right here. All right, I take this number and I divide that by each of these. All right, so we divide by each of those. And then reduce if possible, right? So negative 8 over 2 is a negative 4 over 1. Negative 3 over 2 does not reduce. Now, basically what that means when I change this into my factoring over here is I have a 3x, and then negative 4 over 1 means I have 1x, so just x minus 4. And then 3 over 2 means I have 2x plus 3. And again, like I said, that's not entirely different from the one method that you did in class, but it's a little bit different. So anyway, that's the way that I do that factoring whenever the number in front of x squared is bigger than 1. So there you go. Or you can look back through your notes from section 5, whatever it was, 5.4, 5.5, something like that, for how to do that. All right, example 4, finding the zeros. Again, when you see finding the zeros, what that means is that we want to know what makes this 0. So really what that's asking is, where is this entire function equal to, I forgot the 1 in there. Where is this entire function equal to 0? Okay, and we did this in section 5.6. I believe it was 5.6 where we started this, or 5.5, one of those two. The only difference here is we have more than 2 terms, but it's the same process. All we're doing is taking each of these and setting them equal to 0. And really, you don't even have to do all of this. You can just basically say where it's equal to 0. Excuse me. So, moving this over, add 2. So one of our answers, x equals 2. There's one of them. This one over here, minus 1. X equals negative 1. There's another answer. And over here, minus 3. Minus 3. So last answer, x equals negative 3. Now I want to point something out here because when we get to the last example, it's going to be important that we recognize something. So if we look at this as a negative 2, that produced a 0 at a positive 2. This was a positive 1, produced a 0 at a negative 1. Oops. Let me get rid of that so you can actually see what I'm doing here. Produced a 0 at a negative 1. This was a plus 3 that produced a 0 at a negative 3. Because in the last problem, we're going to work backwards from this, and we're going to try and write a function going from the zeros to standard form. Alright, so this one, again, go ahead, pause the video, try it out, and see what you get for your zeros. So again, hopefully you tried that, and now you're ready to do this. Again, all we're doing is we're taking each of these parts, and we're going to set them equal to 0. Oops. Again, getting ahead of myself. Let's just start that whole thing over again. Alright, set it equal to 0. Add 7. X equals 7. There's one of my zeros. X equals 7. Separate that a little better. X minus 5 equals 0. Doing it again. See if I can erase that without erasing everything. There we go. Alright, add the 5 over. Again, we got to do the opposite. So add 5. X equals 5. There's another 0. Last one, set the last one equal to 0. Again, really all we're doing here is just setting each of these equal to 0. So that's what we're doing. We're trying to find the zeros, so we set them equal to 0. And it's just going to give us the opposite sign of what we have there in the parentheses. Alright, so that's what we got there. Last one, like I said, what we're doing here is we're going backwards. So if it has zeros at these three numbers here, negative 2, 3, and 3, when we write this in our function, all we're going to do is we're going to put opposite signs. So if it produced a 0 at negative 2, like I said earlier, that came from opposite sign positive 2. And then if we had one at positive 3, that came from, again, opposite sign negative 3. And if it had another one at 3, that came from another opposite sign of negative 3. All right, and you can have multiple zeros at the same number. All right, that's not a mistake. Having 3 and 3, that's possible to have two zeros at the same number. All right, so then what we do here is we just multiply this out. So what I'm going to do is recopy one of them. So I'm just going to recopy that first one, x plus 2, kind of just like we did in that first example where we just took that and multiplied that problem out. Same thing here. We're going to do the same exact thing. So we're going to do this here. So x times x, that gives us x squared. X times negative 3, that's negative 3x. And we're going to multiply this through. Negative 3 times x is negative 3x. Last part, negative 3 times negative 3. Negative times negative is positive, 9. And before I multiply that out, I'm going to just clean it up a little bit. So bring down my x plus 2. And then x squared, negative 3x minus 3x. When I combine those together, I get a negative 6x plus 9. Alright, so now I'm ready to start distributing my x plus 2. So x times x, x to the third. Sorry, I think I said x times x. That's x times x squared. And then x times negative 6x. So that's going to give me a negative 6x squared. And last part with the x times 9 is a plus 9x. Take the 2 times x squared. That gives me a plus 2x squared. 2 times negative 6, negative 12x. All right, 2 times negative 6x is negative 12x. And the last part here for our multiplying, 2 times 9 gives us 18. And now we're ready to combine our like terms and get our final answer. So again, if you're not sure about any of those steps, rewind it, make sure you're on the same page before we do this last step. All right, x cubed, there's only one x cubed term, so I'm going to bring that down. We have negative 6x squared plus 2x squared, that's a negative 4x squared. We have a 9x minus 12x, that's a negative 3x. And then we have this plus 18 at the end for your final answer. There you go. Final answer. Right? And that was the last example there. So again, if you have any questions about anything there, just send me an email or send a comment on Google Classroom, and I will get back to you. You got some homework problems, so try those out and let me know if you have any questions on those problems as well. All right, thanks.